Hello students, let us continue the session on mensuration. Question 68. Mukesh walks around a circular track of radius 14 meter with speed of 4 km per hour. If he takes 20 rounds of the track, how long does he walk? Here, as per the given question, a radius of the track is 14 meters. So when the radius is known, we can find out the circumference. So circumference of the circle or circular track is 2 pi r. Let's take pi value as 22/7, multiply to the radius 14, 7 2 times is 14. So on simplification, it's 88 meters. This is the distance covered in one round. Therefore, the total distance covered in 20 rounds we need to find. This will be equal to 88 multiplied to 20, which is 1760 meters. This is the total distance. They have even given the speed of Mukesh on the circular track. The speed given is 4 km per hour. This is 4 km per hour. We can calculate this particular thing in terms of meter per second because the distance we obtained is in terms of meter. So we need to multiply instead of kilometer as 1000 meter divided by instead of 1 hour it's 60 minutes. This can be further simplified. We get it as 200/3 meter per minute. This is our speed. We can find out the time taken. The time will be equal to distance upon speed. Distance is 1760. Speed is 200/3. So we have to reciprocate this and multiply 1760 multiplied to 3 divided by 200. One of the 0 can be cancelled here. When we multiply this and divide by 20, we get 26.4 minutes. We can convert this in terms of minutes and seconds. So this is same as 26 minutes. This 0.4 minutes is nothing but 24 seconds. This is the time taken. Question number 69. The areas of two circles are in the ratio 49:64. Find the ratio of their circumferences. To find the circumference, we require radii. So let's make use of this given. They have given that area of the circles ratio. Say area 1/area 2 is given as 49/64. Since they are circles, I can take area 1 as pi r1 square upon pi r2 square. This is 49/64. This pi get cancels. We have r1 by r2 whole square is equal to 7/49 is 7 square, isn't it? So 7/8 whole square. When we take square root on both the sides, we'll be getting r1 by r2 equal to 7/8. We all know that circumference of circle is given by 2 pi r. We are having r1 by r2. Let's multiply 2 pi to both numerator and denominator. This will be equal to 7 upon 8. Therefore, 2 pi r1 is the circumference of first circle, 2 pi r2 is the circumference of second circle, 7 by 8. The ratio is 7 upon 8. This is the trick to be done. 2 pi to be multiplied to r1 and r2 so that the circumferences are obtained. Question number 70. There is a circular pond and a footpath runs along its boundary. A person walks around it exactly once, keeping close to the edge. If his steps is 66 centimeter long and he takes exactly 400 steps to go around the pond, find the diameter of the pond. Here, to find the diameter, it says 2 times of radius. We don't know exactly what is the diameter. That is what we need to find. Here the person is taking 400 steps with 66 centimeter long to go around the pond. So when we multiply this 66 with 400, we will be getting the circumference of the pond. So circumference is nothing but distance covered by him. He is taking 66 centimeter long step and he is making 400 steps. So this will be 264 followed by 2 zeros centimeters. We can convert this in terms of meters. So we need to divide this by 100. We will be getting 264 meters. This is the distance covered by him. It is same as the circumference of the pond. And we know it's a circular pond. The circumference of circle is given by 2 pi r. 2 pi r is equal to 264. So we can find out the radius. This will be 264 upon 2 pi. Pi value we can consider as 22 upon 7. So 2 to be multiplied with 22. This numerator should be multiplied by 7. On simplification, we get it as 42 meters. This is the radius of the pond. Therefore, the diameter of the pond will be 2 times of the radius. It's 2 times of 42. This will be equal to 84 meters. Question number 71. A running track has 2 semicircular ends of radius 63 meter and 2 straight lengths. Perimeter of the track is 1000 meter. Find each straight length. It is something like this. These are the straight lengths followed by 2 semicircular ends. This is the track. We need to find out this particular thing. If I consider this as L, this will be L. If the radius of this circular end is taken as R, then this circumference is pi r. Towards this side also it is pi r. So one side it is pi r, on the other side also it is pi r. So circumference of one circle is the circumference of these circular ends. This is what is understood from the question. Here you must know that the perimeter of the track is nothing but pi r added to L added to pi r added to L. So it is 2 pi r plus 2L. This is r 1000 meters. They have given the perimeter as 1000 meters. So 1000 is equal to 2 times of 22 upon 7 multiplied to the radius. Radius is 63 plus 2 times of length. 7 9 times is 63. So 44 to be multiplied to 9, we'll be getting 1000 equal to 396 plus 2L. So 2L we can find as 1000 minus 396. So 2L will be equal to 604 meters. With this we can find the length. 604 upon 2 is 302 meters. Question number 72. Find the perimeter of the given figure. Here you can observe that there is 90 degree mentioned over here. When these two sections they are added together, it forms semicircle. 90 degree plus 90 degree together it becomes 180 degree. So the angle which is formed at the central angle is 180 degree, means it is a semicircle. Whenever you have a semicircle of this type, here 290 degrees are there. From here to the center, it is the radius and one more radius. When we observe this particular figure's perimeter is 2r added to half of the circumference of the circle. So it means that 2 pi r should be divided by 2. So it is 2r plus pi r. 2r is 2 multiplied to 6.3 plus pi r is 22 upon 7 into 6.3. So 2 times of 6.3 plus 22 times of 7 into 0.9 gives 6.3. So 2 times of 6.3 is 12.6 plus this will be 19.8. Let's add them together. We get 32.4 meters. This is the perimeter of the given figure. Question number 73. A bicycle wheel makes 500 revolutions in moving 1 kilometer. Find the diameter of the wheel. So the number of revolutions made is 500 and it has moved around 1 kilometer. So the distance in one revolution is nothing but the circumference divided by perimeter of the wheel. So let's solve in this way. "500 revolutions in 500 revolutions, distance covered is 1 kilometer. So in one revolution, distance covered will be equal to 1 upon 500, which is nothing but 1000 divided by 500 in terms of meters. We get it as 2 meters. This is our 1 kilometer. This kilometer is converted into meters now. So 2 meter is the distance covered in one revolution. This is nothing but circumference of the circle. Here it's a circular wheel, so the circumference of wheel is equal to one revolution. Let's mention that circumference of wheel is equal to one revolution. Circumference of the wheel is given by 2 pi r, which is equal to 2 meters. The reason is the distance covered is 2 meters, one revolution distance. So r we can find as 2 divided by 2 pi, which is 2 divided by 2 times of 22. In the numerator we need to multiply 7. We will be getting 7 upon 22. This is the radius. The question they have asked the diameter, therefore diameter of wheel will be equal to 2 times of 7 by 22. It's nothing but 7 by 11. We need to find in terms of decimal. It becomes 0.636 meters. This is the diameter of the wheel. Question number 74. A boy is cycling such that the wheels of the cycle are making 140 revolutions per hour if diameter of the wheel is 60 centimeter. Calculate the speed in kilometer per hour with which the boy is cycling. Let me mention what is given in the question. The cycle is making 140 revolutions per hour. That's one information. Cycle makes 140 revolutions per hour. Here the diameter is given as 60 centimeter, so we can find out the radius. Radius will become 30 centimeter. When the radius is known, we can find out circumference of the circle, that is the distance covered in one revolution. Distance covered in one revolution will be equal to circumference of wheel. This will be 2 pi r, 2 times of 22 upon 7 multiplied to the radius 30. We get it as 188.57 centimeters. Therefore, the distance covered in 140 revolutions will be 140 to be multiplied with 188.57 becomes 26,400 centimeter. Therefore, speed in terms of kilometer per hour will be distance covered in 140 revolution 26400 divided by the time is 1 hour because they have given 140 revolutions are made in 1 hour. So the speed becomes this is in terms of centimeter. This centimeter we can convert in meter. So 26400 divided by 1 hour. This should be multiplied with 1 by 10,000. Sorry, 1 lakh. We get it as 0.264 kilometer per hour. What is done here? We have converted this centimeter in terms of kilometer. We all know that centimeter, if you convert in meter, it is 1 by 100. Meter, if you want to convert in kilometer, we have to multiply one more 1000 to that. So 1000 multiplied to 100 will have 5 zeros. So 1 lakh is considered here to convert centimeter in terms of kilometer. Let's solve one more question for today's session. Question number 75. Find the length of largest pole that can be placed in the room of dimensions 12 meter, 4 meter and 3 meter. You can see here this dotted line. This dotted line indicates the length of the largest pole which can be placed in this cube. They have given the dimension of the cuboid. In this cuboid, this dotted line indicates that this is the length of the pole. When you observe carefully, there is a right angle triangle formed over here with respect to ACF. So we'll take ACF and we calculate. They have given a hint here. The length of AC is nothing but the square root of 12 square plus 4 square. The reason being this is forming a right angle triangle here. So this particular triangle, we are considering this length AF. There is one more right angle triangle formed here with respect to ACF. So in this triangle ACF, square on the hypotenuse is AF square, which will be equal to AC square plus CF square. So AF square will be equal to a square of under root 12 square plus 4 square plus 3 square. The square root and square, they get cancelled. So we get AF square as 12 square plus 4 square plus 3 square. 12 square is 144 plus 4 square is 16 plus 9. Let's add them together. We get 169. So AF will be root of 169, which is 13 meters. So the length of the largest pole which can be placed in this given cuboid is 13 meters. This is an hint. This is very important hint. If this is not known, we cannot make use of the Pythagoras theorem in this triangle. With this question, I'll end today's session. Thank you.